what metrics are you using to measure success?
So success on this goes back to operational efficiency. You know, at CORE, we mine at a profit, which is unusual. If we look back at this we talk about beyond the shoebox. This shoebox, you know, it comes really from the S9, and we've talked about this a lot. The S9 was just a fantastic machine that Bitmain designed, but it was designed really for a lift and shift environment where they were in the Mongolian desert mining, and then during rainy season it lifted to where power was a lot cheaper. That design, as Bitcoin mining spread across the entire globe, was just kind of chased, and we just kind of accepted it. And Bitmain was very good at producing massive amounts of it. And that design also, in turn, led to the infrastructure that we built. If you look at Core Scientific, our first 500 or so megawatts that we built was all built around that S9 shoebox. Well, then Bitmain then took the shoebox and just kind of doubled it for the other things. But if you really sit back and think about it, let's think about what Tesla did with car design and said, listen, if we were just starting from scratch, where would we be? What would be the most efficient way to do this? And that's where we came with Block. It said, if we had to do it again, and at Core Scientific, we've done so many, and we have so many data centers in different locations, said, if we had to do it again, what are some of the things that we would do? And what would we do different? And what would we do to lower our total cost of ownership and speed machines back into production?
I mean, the other thing is when you're looking, you know, at the current manufacturers, the current miners, you know, anyone who's upgraded a regular desktop computer, you don't throw away the power supply, the motherboard, the hard drive when you change your GPU, right? Or you add a second GPU. And so right now, you know, if you're doing that, it doesn't make sense to put a fan that's going to last, you know, well, the lifetime of the miner, or even, you know, ideally longer. But if you know that those components don't need to be replaced, the power supply, the chassis, the fans, you can then use better components because they are now almost infrastructure, whereas it's just the hash boards that you're replacing. And so what that means is there's less downtime, less failures, better components, and it lowers the cost over multiple generations.
Now, the partnership between Core and Block, how did that come about? And what are some of the unique strengths and weaknesses, you can just speak to the strengths actually, of each company that leads to this partnership coming about?
Can we jump in there first?
Go for it.
So, you know, we've actually been working with Perry for years. He was CTO at Argo, and when he was CTO at Argo had a lot of machines with Core Scientific over the years. So Perry's burned up a lot of shit at our facilities before. Now, but we've also learned a ton working with Perry. When he went over to Block, and Block started going deep into the Bitcoin mining space, we actually started working closely with them and was super impressed with their ideas around ASIC design and super impressed with their ideas around total cost of ownership. You know, they started out looking at how can we take this to the home, and then realized, you know, the power profile really didn't work there, but how can we make Bitcoin mining easier to access? And then from an industrial miner perspective at our side, you know, the idea was, look, Block is going to have a machine they're going to go to market with, but they're also designing these fantastic chips. And they were the first ones to let us really go and say, you know what, if we want to design something around how our facilities work and how we operate as a miner, what can we do to do that? You know, what can we do to make that happen? So they've been a fantastic team to work with.
Yeah, I mean, one of the things was, you know, at Block, I think we've built and shipped over 30 million devices. Wow. And, you know, software, the firmware, and, you know, a miner goes down, it's a pain, you got to fix it, but your credit card reader goes down, you don't get paid. There's a big difference. And so the level of reliability and quality that we built to, we wanted to kind of put in the mining space. But for that to happen, you need to understand really well the conditions that these miners run in. They're all, you know, free air cooled, so it's not a controlled environment. Core has facilities, like, you know, Russell said, I've worked with them in the past, from Texas all up to North Dakota, and very different temperatures. And to get that data that, you know, I know Larry always tracks about what breaks, how often, you know, and what temperature, that then allows us to get that information and say, okay, how can we put this into our miner to make sure, you know, that doesn't happen, or we can prevent it. And so that's kind of, you know, the synergy that between the two of us, and we ended up here.
Well, I mean, add also, the work that Perry and I have done in the past, it was how to maximize uptime and how to maximize utilization during that time. And we had a lot of different environments that we had to operate in, and reducing the number of trips to the shelf became important. Perry was a demanding and fair customer. What he needed, we had to supply it. And there's very few people that know as much about how to run a fleet in various conditions, because when you order machines from the current supply routes, you don't necessarily know what you're going to get. You hope that you get the best quality ones that ship, but you have to work with whatever you get. And from two best-in-class groups, and from the expertise over at Block, our collaboration is going to create the best unit for our facilities. And the work that they're doing on their unit is going to create, again, through collaboration, but they're going to create something that works for almost everyone. And having that ability to do that has been removed from us for so long. And so we had to jump at the opportunity to work with him. And of course, working with his engineers has been terrific.
Now, Perry, Block has always been pretty focused on decentralization, from the chairman all the way down. That seems to pervade the culture. How is this partnership furthering that mission of decentralization?
So, anyone who's built a miner, even if you have the ASIC, it's not a very simple endeavor. This is our first go at this, where we're working with a partner. This hasn't really happened before. No one said, here's ASICs, build what you need. And so our goal was always to, the ASIC's the foundation, the building block. To build it, make sure there's great documentation. We currently have the mining development kit. And that was basically the first thing we did with older Intel chips. We wanted to kind of show the developer community, here's a board that you can, even put in works with an S19 form factor, S19 power supply, but tell us what you think. Tell us what we can do better. Give us your feedback. Instead of us just saying, here it is, tell us how we can improve it. And from there, it was, we're going to build our ASIC, work with these guys who have the experience in all these different conditions and have all this data, and there's going to be many more partners, right? Some are going to be at this scale, and some are going to be guys maybe that build, a one-chip board, who just really want to tinker and enjoy mining. So, whether it's 500 chips, 1,000 chips in a machine, or a single chip, something like a BitAxe, what we'd like to do is support everyone in between.
And I'll add, at Core, we have a fantastic relationship with Bitmain, and we bought billions of dollars worth of stuff from Bitmain. But at Block, there was the first ones when we said, here's a problem we're trying to tackle. And very specifically, what we're trying to tackle was facilities we built 2 generations ago. And our operations team come back, and we had a bill of about $20 million to upgrade the electrical infrastructure from what was the S19 to what will be the S21 as the wattage was going up and the voltage was going up. And that was a very specific problem for us, because that was money that was going into non-compute, right? Any dollar you spend going into non-compute is not a productive dollar. And that was the initial problem that we were trying to solve. The Block's answer, or the answer to that question was, well, we can help with that. You don't have to have a machine that's going to be 5,000 or 6,000 watts. And we started looking at that, and that's where we really started going, okay, if we can not have to upgrade our electrical infrastructure and use the existing footprint that we have, how would we fill that existing footprint? How would we make that entire mining facility a one big miner, the most efficient miner that it can be? So, because at Core we look at our facilities as a whole when we look at productivity, because we turn individual machines on and off based on hash price and based on power price. But that was the corpus of the first question that came to mind. And then from there, it really dived into, okay, total cost of ownership. And then it went into, as Perry mentioned, we have sites in North Carolina, Georgia, Kentucky, Texas, North Dakota. And by the way, mining in West Texas and mining in North Dakota are 2 different things. And again, Bitmain is a fantastic manufacturer. They can put out a lot of machines, but they design one machine. And one machine for a global footprint. But mining in West Texas and mining in North Dakota are 2 different things. And what we're able to do with Block is to dive into the minutia of, okay, it's really cold here, but it's really hot and sandy here. Or it's perfect weather in Marble, North Carolina for everything, it's a great little place. So, but those are the kind of things we were trying to address. And the customization optionality of this is just fantastic as an industrial scale miner.
You are correct that the worst thing about Texas is the weather. So we've just got really hot and then really cold, especially out in West Texas.
Summer and not summer.
Yeah,
what I've been
summer and not summer.
Yeah, I had a
I'm going to stick with you, Russell. So long term with Core, how is this project fitting into your strategic goals, and what metrics are you using to measure success?
So success on this goes back to operational efficiency. At Core, we mine at a profit, which is unusual. But it also means we mine every single Bitcoin we mine is at a cash flow positive situation. So our operations team works very hard and Larry's team, we have a software stack and a hardware stack that basically says on a unit basis, if power price and hash price are in the right location, that thing's running. But if it's not running. And this kind of optionality, and by the way, that volatility of hash price and that volatility of power price is going to get more and more important as Bitcoin ages, as the halving, each halving becomes less and less Bitcoin around. So we at Core are looking at this as a measure of efficiency. Like how can we make sure, and how can we, guess what, if hash price goes to 20 cents with these chips, joules per terahash is going to go up, but terahash is going to go up a lot, right? And we want to be able to crank that up. But if hash price goes to 2 cents, we want to be able to crank that down, and we want that very, very low efficiency. And you have to be able to play in that volatility game if you're going to survive as a Bitcoin miner, survive and thrive as a Bitcoin miner. And this kind of optionality on these kind of chips, along with us designing it ourselves or us being involved in the design piece of it, I think it gives us a lot of that optionality in that very volatile market.
I mean, one of the things that, you said 5 years from now or 2 years from now is the way we design this, not just the ASIC, but even, the mining platform is, it's designed with multi-generational upgradability, right? So we're not throwing away perfectly good components. We can reuse as much as we can. Like that saves on shipping. That saves on labor costs and on op costs. And so, something as simple as the fact that when a new generation ASIC comes out, it can work alongside in the same machine as an older one. And that requires close collaboration, planning, but that's the vision starting from today, from 5 years from now.
Okay. Well, I want to pull on that thread a little bit further and just go down the line, starting with you, Larry. 5 years from now, what do you hope looks different about the Bitcoin mining industry than it does today? And how is this innovation leading to that eventual outcome?
I think the decentralization of Bitcoin happens in a lot of ways. It happens, for one, there's lots and lots of different groups that are able to access it through the work that Block is doing to make miners available even to individuals again. That was something that's been cut off for a very long period of time because of minimum order quantities. I think that the units themselves are becoming higher quality. And so the amount of workflows that we have to engineer around this hardware, you'll be able to optimize those parts of the business. And it's going to be around. People need to build on top of Bitcoin, and we need to stabilize it from the ground up. We're the foundation of all these amazing technologies that can be built on it. And I look at the work that we're doing here as just pioneering that next stage. And in 5 years, I'm not sure what 5 years will look like necessarily, but I hope that I'm a big part of it. And I hope that when we build these devices, that we inspire others to be a part of that. And more supply chain, more routes to get equipment, that's decentralization.
Barry?
I hate making predictions because if someone asked me 5 years ago what it would look like, I don't think this would have been the answer where we are today. So 5 years from now, I don't know, but what I do hope for from the mining standpoint is, the way it started where people were mining on CPUs, mining at home, and that's how I started mining, is that may not make sense from a strictly, let's say, economic standpoint because electricity costs are high, but as we, go forward, there's heat reuse application. There's secondary use, mostly for heat, but I've seen, bathhouses in New York. I've seen people, dry timber, smoke salmon with the heat from Bitcoin mining. And so, there's data centers in, I think, Finland and Sweden where they have piping that heats communities that is now being heated with Bitcoin miners. And so that means older machines can do it, different form factors can do it, and I think what Block really wants to make sure is any opportunity that exists, anyone who wants to build something for those things, that they have the ability. They may not have the knowledge right away, but that's where we come in. We want to make sure they have the documentation, the support, whatever we can do from the most niche application to your traditional industrial mining.
So 5 years out, if I look back now, CORZZ, we've been mining through 2 halvings. Me and a couple other folks, including Larry, at the company, have been mining through 3. Some people have done 4 halvings. This will be another one. So 5 years from now, we're going to have gone through another Trump administration. There may be some kind of tariffs on supply chain that's going to create some havoc. We're going to have gone through probably somewhere between 10 and 15 gigawatts of AI demand. And everybody knows CORZZ, we're actively building out 500 plus right now megawatts of critical IT load, which is like 750 megawatts. So think about that, just using CORZZ as an example, that you and I were talking about this, that's 750 megawatts that if we weren't doing AI, we'd be doing Bitcoin mining with it here in the United States. So we're going to have gone through a situation where AI is taking a huge amount of power off the grid for Bitcoin mining. We may have a Bitcoin reserve. The U.S. government may end up buying a million Bitcoin. You may have other governments following that, which means there's not that many Bitcoin in liquidity right now because most people buy and hold. If you buy and hold, who's going to buy this? Where are the transactions actually going to come from? So I say if I look out 5 years from now, if I look back 5 years, there's been an incredible amount of volatility. It's only going to increase. And from a Bitcoin mining perspective, which Bitcoin miners secure the Bitcoin network, and I just talked about the U.S. Treasury and other governments holding as a reserve. Well, secure that network are Bitcoin miners. So it's not only going to become more volatile, but it's going to become incredibly more important to the overall global economy as these things are placed in reserve accounts. So I think Bitcoin miners are going to have to prepare for, first off, more expansion into the global network. Because again, if AI is pushing in the United States, I think we're going to see more Bitcoin mining push out around the globe. Bitcoin mining is very flexible in where it can go. I think you're going to see Bitcoin mining continue to have to chase the incredibly cheap power. So I think as solar and batteries become cheaper and more prevalent, I think we're going to see Bitcoin mining spread out. I think you're going to see the hash rate chase the sun as you're chasing free and cheap power around the globe. I think we're going to see miners get more sophisticated using chips like what Block is, where you're going to have machines sitting on shelves that maybe sit there, half the time and only come on the other half the time whenever things are incredibly cheap. So if I look out 5 years from now, you've got to plan for all of this volatility. You got to plan for the power structure volatility and generation volatility. You got to plan from I would call it competition for the grid that's going to come with AI. I do think one interesting thing is, I was just talking to our head of mining this morning. I said, are the 34s on? He said, yes, sir, they're on over in West Texas. That means we are running at core things we bought 6 years ago. So I think that the network, is going to continue to get bigger and bigger because the efficiency between the chips is going to get smaller and smaller. Now, I think the chips are going to be more valuable to have the flexibility to crank up and go down, but you're still going to see people running those older model efficiency chips whenever when the hash price is high enough that it's profitable. So there's a lot of things going to happen in the next 5 years. I don't know what they all are. It kind of scares me.
Well, I think people underappreciate the benefits of having that flexibility because duck curves are pretty violent things if you look at them on a graph. And Bitcoin mining is only starting to scratch the surface of smoothing out that curve, bringing up the troughs and shaving the peaks. One thing that I thought about when y'all were talking is the fact that there's probably going to be less e-waste as well.
Absolutely.
So speak to that because there's a cost to that I don't think people think about. Anybody who wants to take that one?
Not only will there be less e-waste, there'll be less carbon as a whole if you're not shipping stuff from China or Malaysia. Or power supplies are heavy, chassis are heavy, fans, all that stuff that whether it's coming on a ship or a plane, like that just doesn't need to happen anymore. And if you're making stuff that's a lot more automated, less manual, less labor involved, like the hash board, can be done here. It can be done in the U.S. Miners are already being built, but there's still certain components that are built elsewhere because of low-cost labor. But if you can automate those things, there's a huge potential savings, and then a bonus of less carbon and less e-waste.
Yeah, it's actually massive. Larry probably knows all the numbers better than I do, but like just fans alone, that's 80% of our repairs. If all of a sudden you're using a better fan component and you cut down all those repairs, not only you cut down the repairs, which means you're a more efficient operator, you also cut down on all that waste and all that. It is recycled, but you cut down on all that. Those aluminum chassis, of course, we sell those get recycled, but you cut down on all of that. And people don't think about the fact we lift and shift miners all the time based on power efficiency and the power grid, but it's incredibly expensive to do and wasteful whenever you're loading up that whole thing versus, as he just said, just loading up a couple of hash boards and moving hash boards instead. So the idea is that we can, using this transformation process here, we can really get efficient and stop having all those excess components. We don't need to have new PDUs, new PSUs. We don't need to have new fans. We don't need to have that thing every time we cycle one of these things. So it's pretty exciting to think about.
You can use newer generation boards alongside older ones to make older machines more efficient as well. So, we're trying to check off as many boxes as possible. From an economic standpoint, it just makes sense. Benefit to that is also a lot less waste and man hours.
And at CORZ Scientific, we use every part. If we can't recycle it, there's something that we can probably get out of it. So at the end of life of a hash board, which is a sad moment, it still stays around. We start pulling components off of it. And we keep massive inventories of anything that we think could be useful. I have an archive of many, many past iterations of miners so we can keep analyzing them. When we do have to discard parts, it's a recycling operation. People want these parts from us because they want to convert over the chassis into raw materials. The boards themselves, we do consolidations. We attempt to get the most life out of them. And what we get to do with Block now is we're the perfect candidate for taking that to the next possible level. And what we'll do is we'll design boards that are highly repairable. We'll design tooling in advance for repairing them. We'll put them through a very difficult program that we've established at CORZ Scientific, where we test the limits of where they can operate and how hard you can run them. And we'll create
Including
devices.
sandblasting and beating.
I was going to say, he hits it with a hammer. Is what he does.
There's a hammer involved.
Yeah.
But that's the last step.
Yeah.
There's a lot of steps leading up to that. But we'll create something that is robust and useful for a long time. We didn't expect that the S19s would be around so long, but we've helped that happen. We've taken the units and we've improved them. We've come up with our own repair processes. In this case, we finally get to do it in advance.
Final thoughts from all of you. Anyone have parting thoughts?
I'll just say it's exciting to be able to, there's so many different variables that we can kind of play with when we're, designing a facility, a miner. What can we learn from the traditional data center world? What can we take? There's a lot of stuff they do that, from an expense standpoint, doesn't make sense in the mining. But what they perfected, why wouldn't we do here? And so when we look at total cost of ownership from the facility and the miner, and how can we get that as low as possible, save on man hours, make it more profitable, do a lot of it right here in the U.S. To me, that's kind of the most exciting part.
I'll go next so you can do closes.
Okay.
We build application-specific data centers at CORZ Scientific. I get to build application-specific units. I get to solve problems that are good to have. How to build these things bigger, how to build them more efficient. What we're doing here is exactly what we're doing with HPC. We're taking this opportunity to put together facilities, an application-specific data center that fits this business and that allows us to inspire others to do the same.
And finally, unless something happens, we'll be getting our first batch of these 3 nano chips this month, and Larry and his team will be putting them on some boards. So we'll be mining with blocks, some of blocks 3 nano chips before Christmas. So
That's exciting news. Yeah. Ladies and gentlemen, join me in thanking our panelists for being here today.